Hello everyone and welcome back to our course. In the previous lecture, we learned how to fetch stock data and load it into our Python project. In this lecture, we're going to learn how we can visualize features of that stock data. All right, so let's start with a stock. We can use, for example, Google, which we haven't used before, also known as alphabet stock. All right, so let's create a new code cell and we can reference that stock just by its name, because we made it a global variable. Then we can get one of its columns by accessing its column by its name. So we have here, like you would get a value from an array or a list at its index, we can do the same, but we just have to pass in the name of the column, which is add close. Let's start with that. So we are using one of the columns and we're just getting it from that data frame. So this is how we can grab a column from the data frame. Then we can use the plot function to create a plot out of that data frame. This will allow us to visualize our data. All right, I'm going to run that code cell and look at this. Here we're using the Matplotlib library to create this plot out of the data. So we have here on the y-axis the add close. Then on the x-axis, we have date, and we can do this for any of the columns we want. For example, we could do it with the high column, which represents the high value of the stock on that day. And here we go, we have another graph generated. We have on the y, the high price, and on the x-axis, we have the date, starting with the first day in our data set, which was 1 year ago from today. So we have here a whole year's worth of data. You can see the trend of the alphabet stock climbed quite high. All right, and we can get any kinds of plots we want. So for example, we could take Goog at a different column, for example, volume, and we can call plot again. And if I run this code cell, I am going to see this time the volume. All right. The volume is on the y-axis and the date again is on the x-axis. So the date is by default always the x-axis when you grab a column. You can also specify if you want a legend. So if I set legend to equal true here and rerun my code cell, then I get a little legend here at the bottom that says what the line actually represents. And legends are very useful to have. Typically you always want a legend because often you'll have more than one line on your chart. As well, you can specify the size with the argument fig size. For example, I can change this figure size to, let's do 14 by 6. Right, then I'll rerun this code cell. And okay, now we get a lot larger of a plot here, a lot clearer as well. Okay, next we can create a moving average graph using the column names. So let's do that. I am going to first make a loop. So let's loop through every moving average in our moving average intervals. So what kind of moving average intervals might we want? Well, we can do any range that we want, like 100-day moving average, 20-day moving average. Let's define a list of moving averages. So I'm going to here moving average intervals. And I'm going to create a list of integers. Let's do, for example, you can do 20, 50, and you can do as well 5. So let's do 5, 20, 50. Inside of this loop, we're going to define a variable column name, and we're going to assign it to equal moving average for percentage s days. All right, and then we're going to fill in that percentage with a string of our moving average. All right, and after that we can grab one of our stocks like alphabet, and at the column name we're going to create a new entry. So you can actually put in new entries like this. We're going to assign it to equal Goog at one of the columns like add close dot rolling of the moving average and then dot mean. This is the formula for getting a moving average. This rolling function is going to create a moving average using this specific column that we selected with the help of the mean function as well. All right, now we are going to have 3 new columns that we just created. moving average for 5 days, moving average for 20 days, and moving average for 50 days. So let's now make a plot for every single one of those new columns. Make sure you're outside of the for loop, and we're going to grab our alphabet stock, and we're going to then grab it at several columns. That's why we're using double square brackets here. We'll do add close followed by moving average for 5 days. And note that that's exactly the same as the name I put here, just filled in with one of the days. Then let's do our next new column, which is a string of moving average for 20 days. All right, and then we had one more, which was moving average for 50 days. All right, great. So then we just have to call the plot function on that, and we're going to create a new plot for all of our columns here. All right, so let me then run this code cell and we'll see our results. Okay, look at this. So now we have this chart with 4 different lines. Okay, and I'm going to zoom in here so you can see. On the Y, we have the value of add close at that day. And then on the X, we have the date. And we have 4 differently colored lines. Add close, moving average for 5 days, moving average for 20 days, and moving average for 50 days. Right? I can make this a bit larger just by passing in here the fig size argument. So I'm going to pass in here a figure size of, let's do 14 by 6 again. Then I just have to rerun the code cell. And okay, it's a bit larger now of a graph, so it's easier to read. So we can see here the orange line begins 5 days after the start because it's a moving average for 5 days. The green line begins 20 days after the start because it's using a moving average of 20 days. And the red line begins 50 days after the start because it's using a moving average of 50 days. Awesome, and that is how we can visualize moving average. Next up, we're going to learn how we can calculate daily returns on our stocks. So join me in the next lecture where we will continue our project.